There are 200 billion trillion stars in the observable universe. Each one is a nuclear furnace burning with the power of billions of hydrogen bombs every second. There is more fire in this cosmos than any human mind can process. And yet, if you stepped outside the thin cocoon of Earth's atmosphere and looked in almost any direction, you would see nothing. Pure, overwhelming blackness. Not dim, not faint, black. The universe is on fire, and it still looks empty. For centuries, scientists assumed this was simple, that darkness was just what you got when stars were far away. They were wrong. The darkness of space is not a gap between bright things. It is a message, and what it tells us about reality is far more disturbing than anyone expected. If you enjoy journeys that completely reshape how you see the cosmos, tap that like button and subscribe. Now, settle in and get yourself comfortable. Let's begin. Start counting. Pick any direction in the sky and start counting the stars. You will run out of patience long before you run out of stars. The Milky Way alone contains somewhere between 200 billion and 400 billion of them. Step outside on a clear night far from city lights, and you might see a few thousand with the naked eye. That seems like a lot, until you realize you are seeing less than 100 millionth of our galaxy's total population. Point a modest backyard telescope at any seemingly empty patch of sky, and more stars appear. Point a professional observatory at the same patch, and thousands more emerge. Point the Hubble Space Telescope at the darkest, emptiest speck of sky imaginable. A region so small you could block it with a grain of sand held at arm's length, and even there you will find 10,000 galaxies stacked behind one another at various depths across billions of light years. And our galaxy is just one of roughly 2 trillion galaxies scattered across the observable universe. Multiply those numbers together and you arrive at a figure so enormous it loses all meaning. Somewhere around 200 sextillion stars. That is a 2 followed by 23 zeros. More stars than all the grains of sand on every beach on Earth. More stars than the total number of sounds every human has ever spoken in the entire history of language. Every single one of those objects is a thermonuclear furnace, converting millions of tons of hydrogen into helium every second. Every single one radiates light outward in all directions at 186,000 miles per second. The universe is not merely sprinkled with light, it is saturated with it. Fire is everywhere, in every direction, at every distance, across every conceivable scale. There are stars being born right now in collapsing gas clouds. There are stars dying right now in supernovae that briefly outshine their entire host galaxies. There are red dwarfs that have been burning steadily since before the Earth existed, and will continue burning for trillions of years after our sun is gone. If you could somehow tally the total energy output of every star currently shining in the observable universe, the number would be so large that no human metaphor could contain it. The cosmos is on fire, so here is the question that should haunt you. Why is it dark? Not dimly lit, not faintly glowing, dark. If you have ever looked at the night sky, you already know the answer your eyes give you. Between the visible stars, there is blackness, not a soft, ambient glow, not a warm background haze, just pure, depthless black. You see stars, yes, brilliant ones, faint ones, maybe the misty band of the Milky Way on a clear night, but the spaces between them are empty, and those empty spaces dominate the sky. The darkness is not the exception. The darkness is the rule. This seems perfectly normal to you. You have seen it every night of your life. Of course the sky is dark between stars. What else would it be? And that assumption, that casual, unexamined acceptance of nighttime darkness, is one of the most dangerous traps in all of science. Because if you stop and think carefully about what a universe full of stars should actually look like, you realize the dark sky above you makes no sense at all. The logic is devastatingly simple. Imagine a universe that stretches out forever in every direction. Imagine it is filled uniformly with stars, the way a forest is filled with trees. not clumped in one spot but spread more or less evenly through all of space. Now pick any direction and draw a straight line from your eye outward into infinity. If the universe is truly infinite and truly filled with stars, that line must eventually hit one. It does not matter how far the line has to travel. It does not matter if the nearest star in that exact direction is 1 billion light years away. In an infinite universe, there is always another star farther out. Every single line of sight, no matter where you aim it, terminates on the glowing surface of a star. Not just some directions, all of them. Every tiny patch of sky, no matter how dark it looks to your naked eye, should be occupied by a star at some distance. And if every patch of sky contains a star, the entire sky should glow, not with a faint shimmer. It should blaze with the average surface brightness of a stellar surface. The whole sky, horizon to horizon, should be roughly as bright as the surface of the sun. 5,500 degrees Celsius in every direction. An inferno without escape. You should not be able to see darkness at all. Night should not exist. Now, before you dismiss this as absurd, consider how airtight the reasoning actually is. This is not hand-waving or loose speculation. This is geometry. If you take the universe and divide it into thin concentric shells around the Earth, each shell 1 light-year thick, something remarkable happens. A shell twice as far away has 4 times the volume, and therefore contains 4 times as many stars. But each individual star in that farther shell appears 4 times dimmer because brightness drops with the square of the distance. 4 times more stars, each one quarter as bright. The two effects cancel perfectly. Every shell, regardless of its distance, delivers the same total amount of light to your eye. The Swiss astronomer Jean-Philippe de Chezeaux worked this out with precise mathematics in 1744. His proof was elegant and irrefutable. The first shell contributes a certain amount. The second shell contributes the same amount. The 1,000th shell contributes the same amount. The 1,000,000th shell contributes the same amount. Now stack infinitely many shells together. Each one adds the same dose of light. The total becomes infinite. The sky does not just glow, it explodes with brightness. This is not a fringe idea. It is not the ramblings of an eccentric thinker. It is a mathematically sound deduction from 3 seemingly reasonable assumptions. First, that the universe is infinite in extent. Second, that it has existed forever. Third, that stars are distributed more or less uniformly throughout it. For most of human intellectual history, all 3 of these assumptions seemed perfectly obvious. The universe appeared to stretch endlessly in every direction. Nobody had evidence that it had a beginning, and the stars, while clustered locally, seemed scattered across the heavens without obvious boundaries. If all 3 assumptions are true, the shell argument holds. The sky should be on fire. The person whose name became permanently attached to this contradiction was a German astronomer named Heinrich Wilhelm Olbers. In 1823, Olbers published a paper titled On the Transparency of Space, in which he laid out the paradox in its clearest and most widely read form. He was not the first to notice the problem, not by a long shot. The riddle of the dark night sky has one of the longest intellectual pedigrees in the history of science, stretching back nearly 250 years before Olbers put pen to paper. The English astronomer and mathematician Thomas Diggers was arguably the first to confront the darkness directly. In 1576, Diggers published a revised edition of his father's almanac that included a radical addition. He translated and expanded the Copernican model of the solar system and went further than Copernicus himself, proposing that the stars were not fixed to a single celestial sphere, but scattered outward through an infinite universe. This was a revolutionary claim, and Diggers immediately recognized the problem it created. If stars extended infinitely in every direction, why did the gaps between the visible ones remain dark? His answer was that the most distant stars were simply too far away to be seen. Their light was too feeble. It was a reasonable guess for the 16th century, but it was wrong, because the shell argument proves that faintness of individual stars does not solve the problem. What you lose in individual brightness, you gain in sheer numbers. The totals never decrease. Johannes Kepler took up the question in 1610 in a letter written in support of Galileo's telescopic discoveries. His approach was blunter than Digger's. Kepler looked at the dark gaps between visible stars and declared that the universe must therefore be finite. The darkness was simply the dark boundary wall enclosing a limited cosmos. Where there was no star, there was nothing. It was a clean solution, but it rested on an assumption about cosmic boundaries that later thinkers would challenge fiercely. An infinite universe had powerful philosophical appeal, and many astronomers were reluctant to abandon it. More than a century after Kepler, the celebrated English astronomer Edmund Halley revisited the problem in papers published in 1720 and 1721. Halley sided with Digges, arguing that in an infinite universe, the light from extremely distant stars would simply be too feeble to register. But Chezo demolished this defense with the shell argument we already described. Distance did not save you. Dimness per star was always exactly compensated by a greater number of stars. The darkness could not be explained away by faintness alone. The universe either had to be finite, or something else entirely was going on. By the time Olbers wrote his 1823 paper, the paradox had been circulating among astronomers for nearly 250 years. But Olbers gave it a particularly clear and compelling formulation, and he proposed his own solution. Perhaps, he suggested, there was absorbing material between the stars, dust or gas, that blocked the light from distant regions, preventing it from reaching our eyes. This seemed clever. It offered a physical mechanism for the darkness, but it was fatally flawed, and the flaw was identified soon after by the English polymath John Herschel. If interstellar material absorbed starlight, it would heat up. Over time, it would reach thermal equilibrium with the starlight passing through it, and once it reached that equilibrium, it would glow just as brightly as the stars it was blocking. You cannot hide light by putting obstacles in its path. The obstacles eventually become sources themselves. The darkness demands a deeper explanation. Here is what makes this paradox so unsettling. Every attempt to rescue the bright sky prediction by tweaking details fails. Dust does not work because dust heats up. If interstellar material absorbs starlight over millions of years, that material eventually reaches the same temperature as the stars illuminating it. It begins to radiate its own light. The obstacle becomes the source. You cannot use dust as a shield. Distance does not work because more stars compensate for individual dimness. The shell argument is airtight. Clustering does not work because even if stars are grouped into galaxies, the same argument applies to galaxies themselves. Replace stars with galaxies, repeat the shell argument, and you get the same result. Finite star lifetimes do not work either, because in an eternal universe, dead stars are continuously replaced by new ones, and the average number shining at any given moment remains constant. In an infinite, eternal, uniform universe, the sky should blaze. Every escape route has been sealed. Every clever workaround collapses under mathematical scrutiny. The logic is airtight. The conclusion is terrifying, and it is observably, obviously wrong. Stand outside tonight and look up. The sky is dark. Between the few thousand stars visible to the naked eye, stretches a profound blackness that dominates everything. You can see this with your own eyes without any instruments at all. The night sky is dark, definitively, undeniably dark. Point a telescope at the gaps and you will find more stars, yes, but you will also find more gaps behind them. Wider, deeper, darker gaps that swallow the new discoveries and restore the blackness. The paradox holds on one side, reality holds on the other. Something has to break. For centuries, nobody could figure out what. The breakthrough, when it finally came, arrived from one of the most unexpected sources in intellectual history. In 1848, the American writer Edgar Allan Poe published a lengthy essay called Eureka, which he subtitled a prose poem. Poe was not an astronomer. He was a poet, a fiction writer, a literary critic known for tales of gothic horror and detective mysteries. He had no formal scientific training and no institutional credentials. He dedicated Eureka to the German naturalist Alexander von Humboldt, and he delivered an early version of it as a public lecture to just 60 people at the New York Society Library on February 3rd of that year. His contemporaries mostly dismissed Eureka as eccentric philosophizing. Some of his friends privately called it absurd. Critics described it as overreaching, confused, a strange departure from the literary work that had made Poe famous. But buried within its sprawling metaphysical prose was an insight so profound that it would take professional scientists another half-century to independently rediscover it. Poe reasoned that if the universe had a finite age, if the stars had not been shining forever, then the light from the most distant ones simply had not had time to reach us yet. He wrote that the only way to comprehend the dark gaps between visible stars would be to suppose that the distance of the invisible background was so immense that no ray from it had yet been able to reach us at all. The dark gaps between visible stars were not gaps in space, they were gaps in time. The universe was too young for the accumulated light of all its stars to have filled every line of sight. Darkness was not evidence of emptiness, it was evidence of youth, and by extension, it was evidence that the universe itself had a beginning, that the cosmos was not eternal but had emerged from some initiating event at a definite moment in the past. This was in essence the correct answer, or at least the most important piece of it. Poe grasped intuitively what would take decades of observational astronomy to confirm. The universe is not infinitely old. It has not existed forever. It had a beginning. And because it had a beginning, only a finite amount of starlight has been produced, and only a fraction of that light has had time to cross the distances separating its sources from our eyes. Remarkably, the professional scientific community did not catch up to Poe for more than 50 years. In 1901, the British physicist Lord Kelvin, one of the most celebrated scientists of his era, published a rigorous mathematical paper reaching the same conclusion through formal calculation. The universe's finite age meant a finite amount of light, which meant the sky could be dark without violating any physical law. But Kelvin's paper attracted little attention at the time. It was buried in a scientific landscape preoccupied with other questions. It was not until the 20th century, when Edwin Hubble discovered that the universe was expanding and subsequent observations confirmed the Big Bang model, that the full resolution of the paradox became mainstream scientific understanding. The darkness that had baffled 4 centuries of astronomers finally had an answer, and it was the answer that a poet had guessed in a lecture hall in Manhattan, 60 years before the physicists caught on. But knowing that the paradox has a solution and truly feeling the weight of what that solution means are very different things. Most people hear the resolution and shrug. The universe is not infinitely old. Fine. The light from distant stars has not reached us yet. Makes sense. Problem solved. Move on. This reaction misses everything important, because the darkness of the night sky is not just a quirky puzzle with a neat historical answer. It is a window into the deepest truths about the structure of reality. Every time you look at the black spaces between stars, you are seeing direct evidence that the universe has not existed forever. You are seeing proof that space is finite in what it can show you. You are seeing the consequence of a cosmos where light travels at a fixed speed through distances so incomprehensibly vast that even billions of years of travel cannot fill the gaps. Think about what the paradox really asks. It asks whether the universe has enough fire to illuminate itself, whether the combined output of every star that has ever existed is sufficient to banish darkness from the cosmos. And the answer, the observed answer written across the sky every single night, is no. It is not even close. The universe is losing. Light is losing. 200 sextillion stars burning with unimaginable fury, and the darkness barely notices. That should stop you cold. We are not talking about a close contest here. We are not talking about a sky that is almost bright, that nearly glows, that just barely falls short of the prediction. The night sky is overwhelmingly dark, profoundly dark. The blackness between stars is not a thin margin of failure. It is a crushing, total domination of darkness over light. The universe has been producing photons for nearly 14 billion years across a volume 93 billion light-years in diameter, and the result is a sky that is, for all practical purposes, black. The darkness does not merely win. It wins by a margin so vast that calling it a competition at all feels dishonest. This means the intuitive expectation was not just slightly off, it was catastrophically wrong. The assumptions behind the bright sky prediction that the universe is infinite in extent, eternal in age, and static in structure are not minor errors. They are fundamental misunderstandings of the nature of reality. The darkness tells you that at least one of those assumptions must fail, and in fact, all three of them fail. The universe is not infinitely old. It began approximately 13.8 billion years ago, in an event whose afterglow we can still detect today as the cosmic microwave background radiation. The universe is not static, it is expanding, with space itself stretching and carrying galaxies apart from one another at ever-increasing speeds. Some distant galaxies are already receding from us faster than the speed of light, not because they are moving through space that quickly, but because the space between us and them is growing at a rate that outpaces even photons. And the universe, while possibly infinite in spatial extent, is finite in what it can show us. The observable universe has a hard boundary, not a physical wall, but a horizon defined by how far light has been able to travel since the beginning. That horizon sits approximately 46.5 billion light-years away in every direction, defining a sphere of visibility centered on the Earth. Beyond that horizon, stars may exist in unfathomable numbers, but their light has not had time to reach us. They are invisible. They contribute nothing to our sky. They might as well not exist as far as our eyes are concerned. Every one of these facts was unknown to the astronomers who first grappled with the dark sky paradox. Digges, Kepler, Halley, Chezo, Olbers. They all lived in an era when the universe was assumed to be eternal and unchanging. They did not know the cosmos was expanding. They did not know it had a birthday. They could not have guessed that the very fabric of space was stretching, draining energy from ancient photons and pushing the sources of distant light beyond the reach of observation. The darkness was right in front of them, visible every single night, and it was screaming the answers to questions they had not yet learned to ask. The darkness is not a trivial feature of the night. It is evidence of cosmic structure, evidence that the universe had a birth, evidence that it is changing, evidence that reality has limits on what it can deliver to any single observer, no matter where that observer is located. The dark sky is the universe confessing that it is younger, stranger, and more constrained than common sense would ever predict. And here is where the story takes its most disturbing turn, because everything we have discussed so far explains why the paradox fails. It tells us why the sky is not blindingly bright, but it does not prepare you for how dark space actually is once you move beyond the familiar comfort of Earth's atmosphere and start looking at the cosmos from the outside. The darkness of the night sky as seen from your backyard is a gentle, approachable version of the truth. Streetlights glow at the horizon. The moon washes out fainter stars. The atmosphere itself scatters light, creating a faint luminous background even on the darkest nights. You see a domesticated version of cosmic darkness, softened and filtered through layers of earthly interference. Strip all of that away. Travel to the outer solar system, far beyond the glow of interplanetary dust and reflected sunlight. Point your instruments at the emptiest patches of sky you can find, away from the Milky Way, away from nearby galaxies, away from every identifiable source of light. Measure the absolute brightness of the void between galaxies. In 2024, scientists using NASA's New Horizons spacecraft did exactly this. The probe, now more than 5 billion miles from Earth and well past the orbit of Pluto, turned its long-range reconnaissance imager towards 16 carefully selected patches of deep sky, far above and below the plane of the Milky Way. The team chose these fields specifically to minimize contamination from scattered galactic light, from nearby stars, and from the faint haze of interplanetary dust that plagues every measurement taken from the inner solar system. Then they measured the total light arriving from the cosmos at optical wavelengths. The result, published in the Astrophysical Journal, Place the cosmic optical background at approximately 11 nanowatts per square meter per steradian. That number accounts for the accumulated light of every galaxy that has ever shone over the past 12.6 billion years of cosmic history. 11 nanowatts per square meter per steradian. Stop and sit with that number. The accumulated glow of 2 trillion galaxies, containing hundreds of sextillions of stars, spanning almost the entire history of the universe, producing a background so faint that no human eye could ever perceive it. Not dim, not subtle, functionally invisible, the combined lifetime output of every star in every galaxy, across nearly all of cosmic time, produces a background glow weaker than the faintest whisper of light imaginable. The researchers confirm that this measurement is consistent with the total light expected from all known galaxies. There is no significant excess, no mysterious extra brightness, no hidden sources flooding the cosmos with undetected photons. What you get is what the galaxies produce, and what the galaxies produce is, from any human perspective, nothing. A darkness so thorough that it took a spacecraft 5 billion miles from the Sun, the most sensitive instruments available to modern science, and painstaking subtraction of every foreground contaminant to even detect the glow at all. The sky is not just dark, it is dark in a way that mocks the sheer quantity of fire the universe contains. This is the setup for everything that follows. The paradox told us the sky should be bright. Reality shows us it is black. The resolution involves finite age, cosmic expansion, and the sheer geometry of distance. But the resolution itself contains a deeper shock. The universe is not merely failing to fill the sky with light. It is failing so completely, so overwhelmingly, so decisively, that the combined output of 200 sextillion stars barely registers against the void. The fire is real, the stars are real, the energy pouring out of every stellar furnace in every galaxy, in every corner of the observable universe is real, and none of it is enough. The darkness wins, and it is not even close. What comes next will show you exactly why. Not in vague terms, not in soft analogies, in hard, physical, measurable detail, the kind that dismantles every comfortable assumption you have about the relationship between light and the cosmos it inhabits. Because the reasons the universe remains dark are not just interesting scientific footnotes. They are the most fundamental truths about the structure of reality itself. Distance, expansion, the inverse square law, the finite speed of light, the overwhelming geometry of emptiness. Each one stacks on top of the last. Each one makes the darkness deeper. And together, they reveal a universe that is nothing like what human intuition expects. The night sky is trying to tell you something. It has been telling you every night of your life. And what it is saying is far stranger, far harsher, and far more unsettling than the simple absence of light. The single most important reason the universe is dark has nothing to do with how far apart the stars are or how faint they become with distance. It is simpler than that, and far more profound. The universe has not existed long enough. Light moves at 186,000 miles per second. That sounds fast because it is fast. A beam of light can circle the Earth 7.5 times in a single second. It crosses the distance between the Earth and the Moon in just over 1 second. It reaches the Sun in about 8 minutes. At that velocity, light is the fastest thing in the physical universe. Nothing with mass can match it. Nothing without mass exceeds it. The speed of light is not just a speed. It is a wall, a fundamental limit woven into the structure of space-time itself. And it is nowhere near fast enough. The observable universe spans approximately 93 billion light-years in diameter. That is not a number you can intuit. It is not a distance your brain can hold. But here is what it means in practical terms. Light that left the most distant visible objects started its journey approximately 13.8 billion years ago, when the universe was only a few 100,000 years old and had just become transparent for the first time. Those photons have been racing toward us ever since, crossing the expanding void at the maximum speed the laws of physics allow. And they are only just arriving now, 13.8 billion years of non-stop travel at the fastest speed possible, and those photons are only now hitting our instruments. That is how large the observable universe is. Not large in the colloquial sense, large in the sense that light itself, the fastest phenomenon in existence, requires the entire age of the cosmos to cross it. This means there is a horizon, not a wall, not a barrier, not a physical edge, but a boundary defined by time and speed. Beyond a certain distance, the light from stars and galaxies has simply not had enough time to reach us. Those stars might exist. They might be burning right now with ferocious intensity, but their photons are still in transit. They left their sources millions or billions of years ago and are still crossing the gulf between us. Until those photons arrive, those stars contribute absolutely nothing to the brightness of our sky. They are invisible. Not because they are dim, not because something blocks them, because the universe is too young for their light to have completed the journey. This horizon is not optional. It is not a limitation of our technology or a consequence of our instruments being insufficiently powerful. It is a hard limit imposed by the laws of physics themselves. No telescope that could ever be built, no matter how large or sensitive, can see beyond the observable universe. Because there is no light to collect, the information has not arrived. The photons do not exist in our vicinity. The horizon is not a veil that better technology will lift. It is a wall that the speed of light and the age of the cosmos have built together, and it will never come down. Think about what this does to the bright sky prediction. The old paradox assumed the universe was eternal. In an eternal cosmos, every photon ever emitted by every star has had infinite time to travel. Every line of sight eventually fills with light because there is no time limit on delivery. But reality imposed the harshest possible constraint. The universe began. It has a birthday, and because it has a birthday, only a finite volume of the cosmos can contribute light to our sky. Stars beyond the observable horizon are cosmologically silent. They exist beyond the reach of information itself. The observable universe contains roughly 2 trillion galaxies. That is an enormous number. It is a number that dwarfs any count human beings have ever performed of physical objects on Earth. But it is not infinite. And that distinction, the distinction between a very large finite number and actual infinity, makes all the difference. An infinite number of light sources filling an infinite number of concentric shells produces infinite brightness. A finite number of light sources filling a finite volume does not. The darkness you see every night is the visible consequence of a universe that started. It is the fingerprint of the Big Bang written across the sky in the only language the cosmos knows: silence. But finite age alone does not fully explain how dark the sky actually is. If the universe were static, if space was simply a fixed container in which the stars perform their nuclear work without interference, the finite number of galaxies within the observable volume might still produce a faintly glowing background. Not bright, not blazing, but present. A whisper of accumulated starlight washing across every patch of sky like a faint cosmic twilight. Something detectable, something measurable without heroic effort. The reason the sky is as profoundly and thoroughly dark as it is requires understanding a second mechanism. One that actively drains energy from light even as it travels toward us. Space is expanding. Not in the way objects expand when heated, not in the way a balloon inflates when air is blown into it, although that analogy is sometimes used. Space itself, the fabric of the cosmos, the distance between points in the universe, is growing. It is stretching continuously, and it has been stretching since the moment the universe began. Edwin Hubble confirmed this observationally in 1929, when he discovered that distant galaxies are moving away from us, and that the farther a galaxy is, the faster it recedes. This was not because galaxies were flying through space like shrapnel from an explosion. It was because the space between them was growing. Every second, the distances between galaxies increase. Not because anything is pushing them apart, because the metric of space itself is changing. This expansion has a direct and devastating effect on light. As a photon travels through expanding space, the space it occupies stretches, and when space stretches, the photon stretches with it. Its wavelength increases. Longer wavelengths mean lower energy. A photon that was emitted as blazing ultraviolet light billions of years ago arrives at Earth as feeble infrared radiation. A photon that left its source as visible blue light might arrive shifted all the way past red, past infrared, into the microwave region of the electromagnetic spectrum, completely invisible to any human eye or any optical telescope ever built. This is redshift, and it is not a minor correction. It is a wholesale destruction of visible light across cosmic distances. The effect is cumulative and relentless. A galaxy at a redshift of 1 has had its light stretched to twice its original wavelength. Every photon it emitted has lost half its energy during transit. A galaxy at a redshift of 2 has had its light stretched to 3 times its original wavelength. Ultraviolet photons arrive as near-infrared. Visible blue light arrives as deep red or beyond. A galaxy at a redshift of 10, which we can now observe with the James Webb Space Telescope, has had its light stretched to 11 times its original wavelength. Photons that left that galaxy as intense ultraviolet radiation arrive at Earth as faint mid-infrared light, completely invisible to the human eye, and detectable only by instruments cooled to nearly absolute zero to avoid their own thermal noise overwhelming the signal. The expansion of space did not just dim those photons, it fundamentally changed what they are. Consider the cosmic microwave background radiation, the afterglow of the Big Bang itself. When the universe first became transparent, roughly 380,000 years after the Big Bang, the radiation filling all of space had a temperature of approximately 3,000 degrees Kelvin. It was a blazing orange-white glow, visible light saturating every cubic centimeter of the infant cosmos. If you could somehow transport yourself back to that moment, the entire sky in every direction would have been glowing at the temperature of a red dwarf star. The universe was bright, overwhelmingly, oppressively, blindingly bright. There were no dark patches, there were no gaps. Every direction radiated at 3,000 degrees. The sky was a wall of fire. That radiation still exists. It has not been destroyed. It has not been absorbed. Every one of those ancient photons is still traveling through space right now, hitting every point in the cosmos from every direction. But the expansion of the universe over the past 13.8 billion years has stretched those photons by a factor of roughly 1,100. Light that was once orange-white visible glow has been pulled into microwave radiation with a temperature of just 2.725 Kelvin, less than 3 degrees above absolute zero. The brightest light the universe ever produced has been cooled by expansion into the faintest whisper of radiation, detectable only by specialized satellite instruments and completely invisible to human senses. You are bathed in it right now. It hits your skin from every direction. It passes through the walls of your house, and you cannot feel it or see it because expansion has stretched those once brilliant photons into radiation so weak it carries less energy per photon than the thermal noise in a snowflake. The universe took its own brightness and stretched it into darkness. This is what expansion does to every photon traveling across cosmic distances. The farther the light has to travel, the more space it passes through, and the more that space has expanded during the journey. Nearby stars and galaxies are barely affected. Their light crosses relatively short distances through space that has not expanded much during transit. But light from galaxies billions of light years away has been traveling through space that has been stretching for billions of years. Those photons arrive beaten down, their energy stripped away by the relentless growth of the cosmos. Ultraviolet becomes visible, visible becomes infrared, infrared becomes microwave, microwave fades toward radio waves. At extreme distances, the redshift is so severe that the photons arriving at Earth bear almost no resemblance to the photons that were originally emitted. A galaxy that blazed with blue-white starlight when its photons departed now appears. By the time those photons reach us, as a faint reddish smear detectable only in the infrared, The universe does not just fail to deliver light from distant sources, it actively degrades the light that does manage to arrive, and the expansion is accelerating. In 1998, two independent teams of astronomers studying distant type Ia supernovae discovered that the expansion of the universe is not slowing down under the pull of gravity as everyone expected. It is speeding up, driven by a mysterious component called dark energy, which accounts for roughly 68% of the total energy content of the universe. Space is pushing galaxies apart faster and faster with every passing eon. This means the redshift problem is not stable. It is getting worse. Photons emitted today by distant galaxies will be even more severely stretched by the time they reach future observers billions of years from now. Light that is currently still detectable will eventually be redshifted beyond the reach of any conceivable instrument. The universe is not merely dark, it is getting darker, and the rate at which it is getting darker is itself accelerating. But expansion and finite age, devastating as they are to the brightness of the cosmos, still do not capture the full picture. There is a third factor, one that operates at every distance, near and far, and that punishes the brightness of every star in the sky without exception. It is the simplest and most brutal law in all of physics. The inverse square law states that the apparent brightness of a light source decreases with the square of the distance between you and the source. Not proportionally, not linearly. With the square, a star that is twice as far away is not half as bright. It is 1/4 as bright. A star 10 times farther is not 1/10 as bright. It is 1/100th as bright. A star 1,000 times farther away appears 1/1,000,000th as bright. The fall-off is savage. It is merciless, and it applies universally to every source of light in the cosmos. Here is why this matters beyond the shell argument already discussed. The shell argument demonstrated that in an infinite and eternal universe, the inverse square law cancels with the increased number of stars per shell. But we do not live in an infinite and eternal universe. We live in a finite one. And in a finite universe, where the number of shells is limited, and the outermost shells have their light further degraded by redshift, the inverse square law does not cancel. It dominates. It crushes the contribution of distant stars into irrelevance. Consider our own sun. It is a perfectly ordinary star, not especially bright or dim by stellar standards. From the surface of Earth, roughly 93 million miles away, it is brilliant enough to light entire continents and power photosynthesis across a planet. Now, move it to the distance of the nearest star system, Alpha Centauri, approximately 4.4 light-years away. That is roughly 270,000 times farther than the Earth-Sun distance. The inverse square law says the Sun's brightness drops by the square of that factor. 270,000 squared is approximately 73 billion. The Sun, seen from the distance of the nearest star, would be 73 billion times dimmer than it appears from Earth. It would be a faint point of light, visible to the naked eye on a dark night, but contributing effectively zero illumination to your surroundings. And that is the nearest star. Stars at the center of our galaxy, 26,000 light-years away, are roughly 6,000 times more distant than Alpha Centauri. Apply the inverse square law again, and their individual contributions become staggeringly small. Now extend this to other galaxies. The Andromeda galaxy is 2.5 million light-years away. Stars in Andromeda are so distant that their individual light output, after the inverse square law has had its way, registers as essentially zero. The only reason we can see Andromeda at all is because it contains roughly 1 trillion stars whose feeble individual contributions pool together into a faint smudge barely visible to the naked eye on the darkest nights. 1 trillion stellar furnaces, each burning with nuclear fury, and the best they can manage at 2.5 million light-years is a dim, barely perceptible glow. That is what the inverse square law does. It takes unimaginable power and reduces it to nothing across the distances that define the cosmos. And Andromeda is close. It is our nearest major galactic neighbour. The Virgo cluster, the nearest large galaxy cluster, sits roughly 54 million light-years away. That is more than 20 times the distance to Andromeda. The inverse square law punishes that extra distance savagely. 20 times farther means 400 times dimmer for each individual star. The individual stars in Virgo cluster galaxies are so faint they are lost entirely, swallowed by the distance. Only the combined glow of entire galaxies is detectable, and even that requires serious telescopes to observe. Galaxies at the edge of the observable universe, billions of light years away, have their individual stars reduced to contributions so infinitesimal that no telescope ever built or theoretically possible could detect a single one. The only way to see those galaxies at all is to collect their combined light in massive instruments over exposure times measured in days or weeks. The Hubble Ultra Deep Field, one of the most iconic images in astronomy, required over 11 days of total exposure time, aimed at a single tiny patch of sky to reveal galaxies whose light had travelled for over 13 billion years. 11 days of staring at one grain of sand-sized spot in the sky, and the galaxies that emerged were still barely visible smudges at the ragged edge of detection. But the deepest reason the universe remains dark is not any single one of these mechanisms. It is the geometry of emptiness itself. The universe is not simply large, it is overwhelmingly, structurally, foundationally empty. Stars and galaxies are rare interruptions in an ocean of vacuum that stretches across every scale of cosmic architecture. Start with the space between stars within our own galaxy. The average distance between neighbouring stars in the Milky Way is roughly 4 to 5 light years. That is approximately 25 trillion miles of vacuum between one stellar furnace and the next. If our Sun were the size of a tennis ball, the nearest star at the same scale would be another tennis ball placed roughly 1,200 miles away. Everything between those two tennis balls would be void, not gas, not dust, not dimly glowing plasma, void. A vacuum more perfect than anything humans can produce in a laboratory. This is the environment inside a galaxy, in the comparatively crowded interior of a stellar neighbourhood. The emptiness between stars is not a gap, it is the dominant condition, and our particular region of the Milky Way is not even especially sparse. Near the galactic centre, stars are packed more tightly, with separations measured in fractions of a light year. But even there, the volume of empty space between stars exceeds the volume of the stars themselves by factors of trillions. A star is a sphere typically a few 100,000 to a few million miles across. The gap to its nearest neighbour is trillions of miles. The ratio between the size of the object and the size of the void surrounding it is so extreme that the word empty does not come close to capturing it. A galaxy is not a dense cloud of stars. It is an almost perfect vacuum that happens to contain stars. Now scale up. The distance between galaxies is measured not in light years but in millions of light years. Even the closest major galactic neighbours, like our Milky Way and Andromeda, sit 2.5 million light years apart, and that is the shortest major intergalactic gap in our cosmic neighbourhood. Most galaxies are separated by far greater chasms. Typical separations between galaxies in loose groups measure 5 to 10 million light years. Between galaxy clusters, the distance is stretched to tens of millions of light years, then hundreds of millions. These are not gaps between bright objects. They are abysses of vacuum so thorough that a photon crossing one travels for millions of years without encountering a single atom of anything that could absorb, scatter, or reflect it. The intergalactic medium contains roughly 1 atom per cubic meter, densities so low that terrestrial physics has no equivalent. At these scales, the universe is not a collection of galaxies with space between them. It is an ocean of emptiness with galaxies scattered through it at intervals so vast they beggar every terrestrial analogy. Scale up again. Galaxies are not distributed uniformly. They cluster along filaments and walls of the cosmic web, the largest structure in the observable universe. Between these filaments lie cosmic voids, regions hundreds of millions of light years across that contain almost no galaxies at all. Roughly 80 to 90% of the volume of the observable universe is void space. Not dimly lit space, not sparsely populated space, void. empty in a way that dwarfs every other form of emptiness we have discussed. A single cosmic void can stretch 300 million light-years from one side to the other and contain fewer galaxies than you can count on your fingers. If you could somehow survey the entire observable universe and color-code every cubic light-year by its contents, the overwhelming dominant color would be black. The filaments, the clusters, the galaxies, the stars, the planets, all the matter that exists, all the light that shines, would appear as thin, fragile threads of color suspended in an ocean of darkness so vast it makes the threads themselves almost invisible. This is the geometry of the cosmos, not a city of stars with a few dark alleys, a desert of vacuum with occasional oases of light separated by distances so vast that the light from one oasis cannot meaningfully illuminate the space around the next. The fire exists. The stars are real. Their energy output is staggering, but the volume they must fill is so incomprehensibly larger than the volume they occupy that their combined output vanishes into geometric insignificance. Every factor compounds every other. The universe is finite in age, so only a limited number of stars can contribute. Cosmic expansion drains energy from the photons that do make the journey. The inverse square law crushes brightness with distance, and the overwhelming geometry of emptiness ensures that most of space receives almost no light from any source at any distance. Stack these together, and the result is not merely a dark sky. It is a sky whose darkness is so deep and so thorough that the total visible light arriving from all sources beyond our galaxy, integrated over the entire history of the cosmos, measures just 11 nanowatts per square meter per steradian. The fire of 200 sextillion stars, filtered through the physics of distance, time, expansion, and geometry, arrives as a whisper fainter than nothing. This is not what intuition predicts. Human beings evolved under a sky where the sun lights half the planet and the moon reflects enough light to walk by. Our experience tells us that enough sources will always produce enough light. That brightness scales with effort, that if you gather enough fire, darkness simply retreats. Every instinct we possess about the relationship between light and space was forged in a world where the distances involved were measured in feet or miles, never in light years. The universe took those instincts and broke them across the most extreme distances, the most extreme timescales, and the most extreme geometries that physical reality permits. Each of the mechanisms we have described is individually powerful enough to significantly darken the sky. But the universe does not apply them, one at a time. It applies all of them simultaneously, across every photon, from every source, at every distance. Finite age cuts off the most distant contributions entirely. Expansion drains energy from the photons that do survive the journey. The inverse square law punishes every additional light year of distance with exponentially diminishing returns. And the sheer geometry of emptiness ensures that the sources of light occupy a vanishingly tiny fraction of the total volume those photons must fill. The result is not a marginal failure of brightness. It is a catastrophic annihilation of light by the combined forces of physics. The darkness is not an absence waiting to be filled. It is an active physical outcome produced by the fundamental structure of the cosmos. To put the scale of this failure in perspective, consider a thought experiment. Take every star currently burning in the observable universe, gather all 200 sextillion of them into a single region, and calculate their combined luminous output. Now spread that output evenly across the volume of the observable universe. The energy density of that light, diluted across roughly 3.6 times 10 to the 80th cubic meters of space, produces a radiation field so faint that it barely registers above the quantum noise floor of empty space. The stars are not failing by a narrow margin. They are failing by a factor of billions. There is simply too much space and not enough fire. Not nearly enough fire. And there never will be. And here is what makes this worse than it sounds. Every physical explanation we have given so far tells you why the universe remains dark. It tells you why the bright sky prediction fails. It tells you why the paradox has a resolution. But none of it prepares you for what the darkness actually reveals when you stop thinking about it as a puzzle to be solved and start thinking about it as a description of what the universe fundamentally is. Because the darkness of space is not just the failure of light to fill the void, it is the signature of a cosmos whose architecture, at every scale and in every direction, is dominated not by matter, not by energy, not by structure, but by separation, by distance, by the raw, unyielding emptiness that defines the space between everything that exists. The physics explain the darkness, but the darkness has not yet explained what it means. Everything you have ever touched is almost entirely made of nothing. Your hand, the device you are holding, the floor beneath your feet, the planet beneath that floor, every atom of every object that has ever existed is overwhelmingly empty space. An atom is a nucleus surrounded by an electron cloud, and the distance between that nucleus and its electrons is staggering relative to their sizes. If you enlarged a hydrogen atom until its nucleus was the size of a marble sitting at the center of a major city, the single electron would be a speck of dust orbiting somewhere near the suburbs, roughly half a kilometer away. The arena, the parking lot, the surrounding blocks, all empty. Everything between the marble and the speck is vacuum. The atom is more than 99.99999999999% empty space. You are made of emptiness held together by forces. This is where the story of cosmic darkness takes its deepest turn. Because the emptiness inside atoms is not an anomaly. It is a preview. At every scale of physical reality, from the subatomic to the supercluster, the dominant feature is not substance. It is the gap between substance. Emptiness is not what fills the spaces between interesting things. Emptiness is what the universe is made of, and darkness is simply what emptiness looks like. Scale up from atoms to the solar system and the pattern does not change. It intensifies. The Earth orbits the Sun at an average distance of approximately 93 million miles. That sounds like a number. Here is what it means physically. If you could drive a car at highway speed toward the Sun without stopping, the trip would take roughly 170 years. The Sun itself is enormous, about 864,000 miles in diameter, large enough to fit 1.3 million Earths inside it, and yet the distance separating Earth from the Sun is over 100 times the Sun's own diameter. We think of the solar system as a compact family of planets clustered around a central star. In reality, it is a vast, empty arena where a few isolated worlds trace lonely circles around a single point of light. The nearest planet to us, Venus at its closest approach, is still about 25 million miles away. Mars, at its nearest, is roughly 34 million miles distant. Jupiter, the largest planet, orbits at nearly 500 million miles from the Sun, and Neptune, the outermost major planet, circles at almost 3 billion miles out. Between these worlds there is nothing, not a dimly lit haze, not a scattering of cosmic debris, a few stray dust particles per cubic mile, a thinning wind of charged particles from the Sun. But functionally, structurally, the solar system is empty space containing a handful of objects at colossal separations. The outermost reaches, where comets drift in the Oort cloud, may extend a full light year from the Sun, nearly a quarter of the way to the next star. Within this enormous volume, the total amount of actual matter is vanishingly small. If you collected every planet, moon, asteroid, comet, and grain of dust in the solar system and compressed it into one object, it would amount to less than 0.2% of the Sun's mass. And the Sun itself, though massive by terrestrial standards, is a sphere, roughly 864,000 miles across, floating in a volume that extends trillions of miles in every direction before encountering anything else. The ratio of occupied space to empty space within our solar system is so extreme that any accurate scale model would be functionally invisible. You could place the Sun as a glowing dot on one side of a football field, and the nearest planet would be a microscopic speck a few yards away. The rest of the field, the parking lot beyond it, the roads beyond that, would contain nothing. The solar system is not a crowded neighborhood of planets. It is an abyss of vacuum with a few isolated pebbles scattered through it at absurd distances. If you turned off the sun, the darkness within our own solar system would be almost indistinguishable from the darkness of deep interstellar space. Now step beyond the solar system and into the space between stars. Here the emptiness becomes something else entirely. It becomes a kind of absolute. The nearest star to our sun is Proxima Centauri at a distance of approximately 4.24 light-years. That is roughly 25 trillion miles. A spacecraft traveling at the speed of the Voyager probes, roughly 38,000 miles per hour, would need over 73,000 years to make the journey. And Proxima Centauri is close. It is the nearest star. Most stars in the Milky Way are separated by far greater distances. In the outer regions of the galaxy, where stellar density drops, neighboring stars can be 10 or 20 light-years apart. In the galactic halo, ancient stars orbit in near total isolation, separated from their nearest companions by hundreds or thousands of light-years of void. The interstellar medium that fills this space between stars is not truly empty in the strictest sense. It contains a thin scattering of hydrogen atoms, dust grains, and the occasional molecule, but the density is almost incomprehensibly low. In typical regions of interstellar space, you might find 1 atom per cubic centimeter. Compare that to the air you are breathing, which contains roughly 25 million trillion molecules per cubic centimeter. The interstellar medium is a vacuum more perfect by a factor of 10 to the 19th power than the air in your lungs. If you were placed in the middle of interstellar space with no suit and no ship, the darkness and emptiness around you would be so total that aside from distant points of starlight, you would perceive literally nothing. No sound, because sound requires a medium to propagate and there is no medium. No pressure, because the density of gas is functionally zero. No temperature you could feel, because there are not enough particles impacting your skin to transfer thermal energy in any meaningful way. Only void, in every direction, extending for trillions of miles. You would see stars, bright ones nearby, dim ones farther out, the faint band of the Milky Way if you happen to be within the galactic disk. But the overwhelming visual reality would be blackness. The points of light would feel like errors in the fabric of the darkness, tiny exceptions in a field of total absence, and the distances between those points would feel not merely large but malicious, as if the universe had been specifically designed to ensure that no fire could ever meaningfully touch the space around any other fire. This is the reality of interstellar space, not the romantic void of science fiction with its dramatic nebulae and colourful backdrops. A blackness so thorough, so structural, so overwhelming that the light within it feels not just faint but accidental. This is the environment inside a galaxy, inside one of the supposedly dense, bright, star-filled structures of the cosmos. The Milky Way contains between 200 billion and 400 billion stars spread across a disk roughly 100,000 light-years in diameter and about 2,000 light-years thick. That sounds packed. It sounds like a region dense with luminous objects. It is not. The vast majority of the galaxy's volume is vacuum between stars. If you represented the galaxy as a volume and asked what percentage of that volume is occupied by actual stellar matter, the answer would be so small it would require scientific notation to express. Stars are tiny compared to the distances separating them. Each one is a sphere of plasma a few 100,000 to a few million miles across, floating in a void trillions of miles wide before the next one appears. You could remove 99.999999% of the galaxy's volume and lose nothing but empty space. The galaxy is space. The stars are rounding errors. The light they produce illuminates their immediate surroundings and then falls off so rapidly with distance that a few light-years out, their contribution to the ambient brightness of their neighborhood is negligible. Each star is a single lit match in a cathedral so vast that its glow dies long before reaching the nearest wall. Now leave the galaxy entirely. Step into intergalactic space. Here the void takes on dimensions that break the analogy engine of the human brain. The nearest major galaxy to our own is Andromeda at 2.5 million light-years. Between us and Andromeda there is essentially nothing. A scattering of hydrogen so diffuse it barely qualifies as matter. A few atoms per cubic meter, compared to the already ghostly 1 atom per cubic centimeter of interstellar space. Intergalactic space is roughly 1,000,000 times emptier than the emptiness between stars. Temperatures hover within a few degrees of absolute zero in the deepest voids, though the diffuse intergalactic medium in some regions can reach millions of degrees. A paradox explained by the fact that when you have almost no particles but those particles carry high individual energy, the temperature is technically extreme, but there is nothing present to feel it. No stars inhabit this gulf. No planets. No structures of any recognizable kind. If you could somehow survive and float in the center of this intergalactic abyss, the Milky Way and Andromeda would appear as faint glowing patches on opposite horizons, each a smear of combined starlight too distant to resolve into individual points. Between them, the sky would be the deepest black any conscious being has ever experienced. No earthly darkness comes close. Not caves, where scattered photons from bioluminescent organisms or distant entrances still faintly illuminate the air. Not the deep ocean floor, where thermal vents and bioluminescence create occasional points of light. Not the darkest moonless night on Earth's most remote peak, where the atmosphere itself still scatters trace starlight into a faint glow. Those environments still contain atmosphere, still contain molecules that interact with light. Intergalactic space contains none of that. The darkness there is not the absence of illumination. It is the absence of everything that could be illuminated. But even intergalactic space is not the emptiest environment the universe has to offer. That distinction belongs to the cosmic voids, the vast bubbles of almost total emptiness that dominate the large-scale structure of the cosmos. To understand cosmic voids, you first need to understand the architecture they belong to. The universe is not a random scattering of galaxies through space. When astronomers mapped millions of galaxies in 3 dimensions, measuring not just their positions on the sky but their distances using redshift, a pattern emerged that nobody expected. Galaxies are not spread evenly. They concentrate along enormous filaments and walls, thin structures stretching hundreds of millions of light-years across the cosmos, like the strands of a 3-dimensional web. Where multiple filaments intersect, galaxy clusters form, dense knots of thousands of galaxies bound by gravity. These clusters are the nodes of the cosmic web, the densest, most crowded environments in the universe. But between the filaments, between the walls, between the clusters, lie the voids, and the voids are enormous. Individual cosmic voids can measure 200, 300, even 500 million light-years across. The Botez void, one of the first large voids to be discovered back in 1981, stretches roughly 330 million light-years in diameter and contains fewer than 60 known galaxies. For comparison, a sphere of that size in a typical region of the cosmic web would contain thousands. The Botez void is not merely underpopulated, it is a desert on a scale that makes terrestrial deserts look like crowded cities. Simulations and surveys confirm that voids occupy the majority of the cosmic volume. Estimates vary depending on how you define a void boundary, but most analyses place the figure between 70 and 90%. Filaments, those luminous threads connecting galaxy clusters, contain roughly half of all ordinary matter in the universe, yet occupy a relatively slender fraction of the total volume. The clusters themselves, the densest and brightest nodes of the web, contain significant mass but take up a negligible amount of space. The universe is mostly void. The filaments, walls, clusters and galaxies, all the structure that contains all the stars that produce all the light, occupy a minority of the total volume, somewhere between 10 and 30%. Everything else is emptiness so thorough that light from the nearest galaxy might take tens of millions of years to cross it. This is the architecture of darkness. Not a uniform scattering of faint light across an even cosmos, but a web of bright threads separated by chasms of nothing. Picture it in 3 dimensions. Thin, luminous filaments, thinner than spider silk relative to the bubbles they enclose, tracing the edges of enormous dark spheres, galaxy clusters glowing at the intersections like tiny jewels at the junctions of a net, and between them, occupying the overwhelming majority of the volume, blackness, not dimness, not shadow, structural blackness built into the geometry of the cosmos itself. The void is not where the universe failed to put galaxies. The void is where the universe chose to put most of itself. The cosmic web was not always this pronounced. In the early universe, shortly after the Big Bang, matter was distributed almost uniformly. The density variations were tiny, roughly 1 part in 100,000, barely perceptible ripples in an otherwise smooth ocean of primordial gas. But gravity amplifies asymmetry. It is patient and it is relentless. Over billions of years, slightly denser regions pulled in surrounding matter, growing denser still, while slightly underdense regions lost matter and became emptier. The rich got richer, the empty got emptier. Filaments formed where matter streamed toward emerging gravitational wells. Voids opened up where matter had been evacuated. The cosmic web is the result of billions of years of gravitational sorting, a process that has progressively concentrated light-producing matter into an ever smaller fraction of the total volume while surrendering the rest to expanding darkness. Matter flows out of voids and into filaments over cosmic time, pulled by gravity toward the denser regions. This means voids are getting emptier. The little matter they contain is draining away, accelerated by the gravitational pull of the surrounding web and by the expansion of space within the void itself. Dark energy, which drives the acceleration of cosmic expansion, operates most freely inside voids because there is almost no matter to resist it. Voids expand faster than the cosmic average. They are growing, thinning, darkening further. The universe is not approaching equilibrium between light and dark. It is tipping further in favor of emptiness with every passing eon. And here is something that connects all of these scales together into a single devastating realization. The universe is not dark despite having structure. It is dark because of its structure. The cosmic web is a separation engine. It concentrates matter into narrow filaments and tiny nodes, while leaving the vast majority of space empty. Stars form only in the densest peaks within those filaments, inside galaxies, inside molecular clouds, inside regions where gravity has managed to compress gas to the point of nuclear ignition. Each of those conditions is rare. Each is a winnowing. Start with all the matter in the universe. Most of it is dark matter, which does not produce light at all. Of the remaining ordinary matter, most is diffuse hydrogen gas in the intergalactic medium, too thin and too hot to form stars. Of the gas that does collect into galaxies, most sits in the outer regions where densities are too low for star formation. Of the gas that reaches sufficient density, most forms low-mass red dwarfs that produce very little visible light compared to their more massive cousins. Only a tiny fraction of all the matter in the universe ends up in stars bright enough to significantly illuminate their surroundings, and those stars occupy a fraction of a fraction of a fraction of the total volume. The numbers are humbling. Ordinary matter makes up roughly 5% of the total energy content of the universe. Of that 5%, only a small fraction resides in stars. Most is diffuse intergalactic gas. Stars themselves account for less than 1% of the total mass energy of the cosmos. Less than 1%. The other 99% is dark matter, dark energy, and diffuse gas that produces no visible light whatsoever. The universe is illuminated by less than 1% of its own contents, and that 1% is scattered across a volume so immense that the light cannot bridge the gaps. This brings us to the most haunting feature of the cosmic darkness. The universe once tried to fill itself with light, and failed. We already know what expansion did to that primordial glow, how it drained 3,000 degrees of radiant plasma into a faint microwave whisper barely above absolute zero. But consider what that transformation means in the context of everything we have just seen about cosmic structure. The cosmic microwave background was the universe's one and only successful attempt at filling all of space with light. For a brief window after the Big Bang, it worked. Every direction was bright. Every line of sight terminated in radiance. The bright sky prediction was, for that one fleeting epoch actually true, and then expansion dismantled it. Over billions of years, the stretching of space converted the only genuinely universal light source in cosmic history into radiation so feeble it is invisible to every biological eye that has ever existed or ever will exist. The one time the universe managed to be bright everywhere, it could not hold that state. The glow lasted a few 100,000 years. The darkness that replaced it has lasted 13.8 billion years so far, and will continue effectively forever. This means the universe tried to illuminate itself, and the architecture of expansion, distance, and time defeated that attempt so thoroughly that the remnant is now colder than the surface of Pluto. The cosmos did not merely fail to stay bright, it failed in a way that is permanent, irreversible, and accelerating. The only universal light the cosmos ever produced has been stretched into a ghost that no eye will ever see. Stars, which appeared roughly 150 million years after the Big Bang when the first gas clouds collapsed, are themselves a temporary interruption of the darkness. Astrophysicists Fred Adams and Gregory Laughlin named the current period of cosmic history the Stelliferous Era, the Age of Stars. It stretches from approximately 1 million years after the Big Bang to roughly 100 trillion years from now, when the last red dwarf exhausts its hydrogen fuel and fades to black. 100 trillion years sounds like an unimaginably long time, and it is. But compare it to what comes after, the degenerate era, when only stellar remnants remain, white dwarfs slowly cooling, neutron stars gradually fading, brown dwarfs too small to have ever truly shone, stretches from roughly 10 to the 15th to 10 to the 39th years after the Big Bang. During this era, the universe still contains matter but produces almost no light. Occasionally, two white dwarfs might collide and trigger a brief thermonuclear flash, a Type Ia supernova, that illuminates the surrounding void for a few weeks before fading. These events are the last gasps of a dying epoch of luminosity. Brief, rare, separated by trillions of years of absolute darkness. After the degenerate era comes the black hole era, which continues until roughly 10 to the 100th power years from now. During this incomprehensibly long epoch, black holes are the only significant objects remaining. They slowly evaporate through Hawking radiation, a quantum process so gradual that a black hole with the mass of our Sun would take 10 to the 67th years to fully dissipate. Supermassive black holes at the centers of former galaxies last even longer, but eventually they too vanish, converting their mass into the faintest possible trickle of radiation. After that comes the dark era, an eternity of cooling, expanding, featureless void. No stars, no remnants, no structure, no warmth. Just elementary particles drifting through an ever-expanding darkness with decreasing energy and vanishing density, approaching but never quite reaching absolute zero. Forever. The dark era has no end. It simply continues, growing colder and emptier and more silent, for a duration that makes every previous era look instantaneous. The Stelliferous Era, our era, the era of stars and galaxies and light, is a brief flicker in the timeline of the universe, a flash, a passing phase. Stars are not the permanent fixtures of a luminous cosmos. They are temporary chemical reactions running on a finite fuel supply, in a universe that was dark before they appeared and will be dark long after they are gone. The darkness of space is not a problem that stars are slowly solving. The darkness is the default state. Stars are the interruption. And the interruption is almost over, cosmologically speaking. Consider what this means for anyone or anything living in the universe at any point in its history. Before stars formed, the cosmos was dark. After stars die, the cosmos will be dark again. The window of time in which any observer anywhere can look up and see luminous objects in the sky is finite. It is not even a large fraction of the universe's total timeline. The Stelliferous Era spans from roughly 1 million to 100 trillion years after the Big Bang. That is approximately 10 to the 14th years of stellar light. The dark era that follows will last at minimum 10 to the 100th years, and likely forever. If you laid out the entire future history of the cosmos on a ruler stretching from one end of a football field to the other, the stelliferous era would occupy a mark so thin that no human eye could resolve it. Less than the width of a single atom on that ruler, everything before it and everything after it is darkness. We happen to exist during the one brief moment when the universe contains fire. We look up and see stars and assume that brightness is normal. That light is the baseline, that the universe is fundamentally a place of illumination peppered with occasional patches of darkness. We build our intuitions, our metaphors, our entire sense of what the cosmos is, on the assumption that stars are permanent features of a luminous reality. The truth is exactly the reverse. The universe is fundamentally a place of darkness, occasionally interrupted by light. The interruption has lasted roughly 14 billion years so far, and has perhaps another 100 trillion years to run. Then it ends. And what follows is not another era of different light. It is an eternal darkness that makes the current cosmic void look crowded by comparison. Everything about the structure of the cosmos points in the same direction. Atoms are mostly empty. Solar systems are mostly empty. Galaxies are mostly empty. Galaxy clusters are mostly empty. The cosmic web is mostly void. The timeline of the universe is mostly dark. The future of the universe is entirely dark. Matter is rare. Light-producing matter is rarer still, and the volume that light must cross to connect one bright object to another is so vast, so overwhelmingly dominant, that the fire of 200 sextillion stars cannot make a meaningful impression on it. The universe did not accidentally end up dark. It is architecturally dark, structurally dark, dark in its bones, at every scale, in every direction, across every epoch of its history. The darkness is not an error in the architecture, it is the architecture. Light is what happens when gravity manages, in rare and temporary circumstances, to compress enough matter into a small enough space to trigger nuclear fusion. Everything else, everything that is not that narrow exception, is void. What comes next is not more explanation. The physics is clear, the structure is mapped, the mechanisms are understood. What comes next is the question that all of this evidence forces you to confront. A universe containing unimaginable fire that still looks overwhelmingly empty and black. A cosmos where brightness is the exception, not the rule. Where distance and separation and void define reality far more than light ever could. The darkness is not hiding something. It is showing you something. And what it shows you about the nature of the universe and about what it means to exist inside it is the harshest truth of all. Every second, our sun converts approximately 4 million tons of its own mass into pure energy. 4 million tons of hydrogen squeezed into helium through nuclear fusion at temperatures exceeding 15 million degrees. The energy released by this single, perfectly ordinary star in 1 second exceeds the total energy consumed by human civilization across its entire history. 1 second of sunlight contains more power than every engine, every generator, every fire, every electrical grid, every nuclear reactor that humanity has ever built, combined and multiplied by a factor of millions. And the sun is unremarkable. It is a middleweight star in a galaxy that contains hundreds of billions of them. Blue supergiants burn hundreds of thousands of times more fiercely. Red supergiants swell to diameters that would engulf the orbit of Jupiter. Across the observable universe, stars in every stage of life and death pour energy into the void with a ferocity that beggars every metaphor. The total luminous output of the cosmos is approximately 3 times 10 to the power of 49 watts. Written out in full, that number stretches past human comprehension long before you finish counting the zeros. And it does not matter. All of that fire, all of that fury, all of that staggering, inconceivable energy production happening simultaneously across 200 sextillion stars, and the universe is dark. Not slightly dim, not faintly glowing, dark. The blackness between galaxies is not a thin veil waiting to be burned away by enough stellar output. It is the permanent, structural condition of nearly all of space. The fire is real, and the darkness is winning, and it is not a close contest. It has never been a close contest. The universe has been producing light for nearly 14 billion years, and the result, measured from the outer solar system, where interplanetary dust no longer contaminates the reading, is a background glow, so faint it required a spacecraft 5 billion miles from home and months of careful calibration to even detect. 200 sextillion furnaces burning for billions of years, and the product of their collective effort is 11 nanowatts per square meter per steradian, a number so small it has no physical analogue in daily human experience. The combined lifetime output of every star that has ever shone produces a background indistinguishable from nothing. This is the central truth that the darkness of space reveals, and it is a truth that contradicts everything human intuition expects. We evolved on a world where light behaves the way we think it should. Strike a match and the surrounding air brightens. Build a campfire and the clearing glows. Gather enough candles in a room and every corner becomes visible. Light, in human experience, fills space. It radiates outward from its source and conquers the darkness around it. Given enough sources, darkness simply yields. This is not a belief we were taught. It is a conviction embedded in the architecture of our perception, built into the visual cortex that evolved to navigate an African savanna where firelight meant warmth, safety, and survival. Our brains assume, at the deepest level, that sufficient fire produces sufficient light and that sufficient light eliminates darkness. The universe does not work this way. The distances are too large, the expansion is too relentless, the geometry is too tilted toward emptiness. A campfire lights a clearing because the clearing is 30 feet wide. A city glows because its boundaries extend a few dozen miles. The visible sphere of illumination around a campfire and the visible sphere around a city both operate in a world where the distance to the next source of light is manageable, where photons arrive in sufficient density to trigger a response in the human eye or on a camera sensor. But the space between stars spans trillions of miles, and the space between galaxies spans quintillions. The distances involved are not merely larger than terrestrial distances. They are larger by factors so extreme that the comparison itself becomes meaningless. At those distances, even the most powerful stellar furnace becomes a pinprick of light detectable only by instruments of extraordinary sensitivity. The light does not fill the surrounding space, it barely dents it. The radius of illumination around any given star, measured in terms of the volume of space it meaningfully brightens, is negligible compared to the gulf separating it from the next star. Each star is an island of warmth and light, and each island is surrounded by an ocean of vacuum so vast that the light from one cannot warm the waters around the next. This is not a poetic metaphor, it is a physical description. If you could travel to the midpoint between our Sun and Alpha Centauri, roughly 2 light-years from each, and measure the total illumination reaching you from both stars, the number would be effectively 0. You would be floating in darkness so complete that your eyes, even after hours of adaptation, would detect nothing. No glow on the horizon, no faint haze, no ambient shimmer. 2 nuclear furnaces, each converting millions of tons of matter into energy every second, and at the halfway point between them, you are in absolute night. Multiply this scenario by every pair of neighboring stars in every galaxy, in every cluster, in every filament of the cosmic web, and you begin to understand the scale of the failure. Light does not fill the space between its sources, it cannot. The distances are not just large, they are large in a way that renders stellar output cosmically irrelevant across the gaps. And what is true between stars is even more devastatingly true at the largest scales. Imagine being placed not between 2 neighboring galaxies, but at the dead center of a cosmic void, one of those bubbles of emptiness, 300 million light-years across, that dominate the architecture of the cosmos. Here, the nearest galaxy is not millions but tens of millions of light-years away in every direction. There are no faint glowing patches on the horizon. There are no smears of combined starlight hinting at distant structure. There is nothing. The sky in every direction is black to a depth that no instrument you could carry would register as anything other than 0. Temperatures sit fractions of a degree above absolute 0. The density of matter around you is so low that you might drift for a volume the size of a large building and never encounter a single atom. No photon of visible light arrives from any direction. No sound, no heat, no structure, no reference point of any kind. Just expanding vacuum in every direction, growing colder and more diffuse with each passing moment. The only radiation present would be the cosmic microwave background, the ancient afterglow of the Big Bang, now stretched to wavelengths so long and energies so low that it carries less warmth per photon than the thermal jitter of a single molecule at room temperature. You would be immersed in it and feel nothing, see nothing, know nothing except the crushing, endless, featureless dark. This is what most of the universe actually looks like. Not from a poetic distance, not as an abstraction. This is the physical, measurable, confirmed reality of the overwhelming majority of cosmic volume. Darkness is not what fills the gaps between interesting places. Darkness is the terrain. Galaxies and stars and planets are the gaps, the rare fleeting deviations from the norm. And it applies not just to our local neighborhood, but to every neighborhood. An alien civilization in a galaxy 5 billion light years from here, looking out at their own sky, would see the same thing. Darkness between their stars, darkness between their galaxies, darkness stretching in every direction toward a horizon they can never reach. It would not matter how advanced their technology was. It would not matter how sensitive their instruments were. The darkness is not a problem of detection. It is a property of the cosmos. No location in the observable universe is bathed in ambient starlight. No world anywhere is illuminated by the combined glow of distant stellar populations, the way a city street is lit by nearby buildings. Every inhabited planet, every possible civilization, every observer that has ever existed or could ever exist, looks out at a sky dominated by blackness. The darkness is not a local condition. It is universal. It is the one experience every conscious being in the cosmos must share. Whether they evolved around a red dwarf at the edge of a spiral galaxy or in the dense core of a giant elliptical, the view is the same. Stars overhead, blackness between them, and the blackness always wins. And the darkness is growing. The universe is not merely dark today. It is darker than it was yesterday, and it will be darker still tomorrow. Star formation across the cosmos peaked approximately 11 billion years ago, when the universe was only about 3 billion years old. At that moment, galaxies were furiously converting gas into stars at rates dozens of times higher than anything occurring today. That era, sometimes called cosmic noon, was the brightest the universe has ever been or will ever be. Since then, the rate of star formation has been declining steadily. Today, the cosmos produces new stars at roughly 3% of its peak rate. The fire is going out, not suddenly, not catastrophically, but slowly, steadily, irreversibly. The fuel is running low. Galaxies form stars from cold molecular hydrogen gas. That gas was abundant in the early universe, feeding the great stellar boom of cosmic noon. But stars consume gas. Supernovae blast it out of galaxies. Active galactic nuclei heat it until it can no longer collapse into the dense, cold clumps that star formation requires. Over billions of years, the reservoirs of cold gas have been drained, dispersed, heated, or rendered chemically unusable. What remains is increasingly sparse, increasingly difficult to gather, and increasingly incapable of sustaining the star formation rates of the past. Astronomers estimate that more than 95% of all the stars that will ever exist have already been born. Even if the universe persists forever, no more than 5% additional stars will ever form. The cosmic factory is shutting down. The assembly line has already produced almost everything it ever will. Half of all the stars that exist today were born during a burst of activity between 11 and 9 billion years ago. It took more than 5 times as long to produce the other half. And from this point forward, the universe will form fewer and fewer new stars with each passing billion years, asymptotically approaching a rate of 0. The Milky Way remains a relatively healthy star-forming galaxy. Roughly 1 to 2 new stars ignite within it each year. but many galaxies have already gone dark. Giant elliptical galaxies in the cores of galaxy clusters exhausted their gas reserves billions of years ago. They contain only aging red stars, slowly cooling, slowly fading, producing no new light to replace what is lost. These galaxies are previews of the universal future. What has happened to them will eventually happen to every galaxy everywhere. This means the era of starlight is not a permanent feature of the cosmos. It is a phase. We already traced its boundaries. We already saw how the timeline of cosmic history dwarfs the age of stars into a sliver so thin it vanishes against the eternity that follows. But knowing the timeline and feeling its weight are different things. What the physics described in terms of structure, this moment demands you absorb in terms of meaning. The last red dwarfs in the universe, those trillions of dim, patient furnaces that make up roughly 70% of all stars in the Milky Way, have not yet aged. Not a single one, anywhere in the observable universe, has reached the later stages of its life cycle. Every red dwarf that exists is still a newborn by its own standards. They will outlive our sun by a factor of 1,000. They will outlive every blue giant, every yellow star, every luminous object in the current sky. And when they are gone, there is nothing behind them. No second generation of brighter stars, no reserve fuel tank, no cosmic mechanism for reigniting what has burned out. The fire does not restart. The universe does not get a second act of brightness. What comes after is not another kind of light. It is the permanent condition that existed before stars and will exist after them. A darkness so total and so enduring that the stelliferous era, our era, the entire age of stars and warmth, compresses to a fraction of the first page in a book whose remaining chapters stretch past the reach of any number system human beings have ever devised. The cosmic microwave background, that faint afterglow of the Big Bang that represents the closest the universe ever comes to a uniform glow, will not last either. Expansion continues to stretch those ancient photons to longer and longer wavelengths. In a few trillion years, the cosmic microwave background will have been redshifted so far beyond the microwave band that it will become undetectable by any instrument conceivable under known physics. The last whisper of the universe's primordial brightness will fade into silence. After that, no background radiation of any kind will fill the cosmos. The darkness will be total, not the partial darkness of the present era, where a sensitive enough instrument can still detect faint signals from ancient sources. Absolute darkness, everywhere, in every direction, for every observer. Future astronomers, if any exist in that distant epoch, will inherit a cosmos that has erased its own history. Galaxies beyond the local group will have been carried past the cosmic horizon by accelerating expansion, vanishing one by one into unobservable distance. The evidence for the Big Bang will have disappeared. The cosmic microwave background will be gone. The expansion of the universe will be undetectable because there will be no distant galaxies left to recede. Redshift, the very phenomenon that revealed expansion in the first place, will be unmeasurable because there will be nothing left to redshift. A civilization arising in that era would look out at a sky containing only its own merged local galaxy, a single island of aging stars surrounded by perfect, featureless, eternal blackness stretching in every direction to a horizon that reveals nothing. They would have no way of knowing that the universe was ever anything else. They would conclude, reasonably and incorrectly, that their island of stars was all that existed, floating alone in an infinite, static, unchanging void. The darkness would have swallowed not just the light, but the evidence that there was ever light to swallow. The cosmos would have hidden its own story. This is not speculation. This is not a pessimistic interpretation of uncertain data. This is the confirmed trajectory of the cosmos under the standard model of cosmology, supported by every major observation of the past 3 decades. Measurements of the cosmic microwave background, of distant supernovae, of galaxy distributions, of the cosmic optical background, all point to the same conclusion. The universe is heading toward a state of permanent, irreversible darkness. The stars we see tonight are not the prelude to a brighter future. They are the last embers of a fire that peaked billions of years before our planet formed and has been dying ever since. We are watching the tail end of the brightest epoch the cosmos will ever know. Sit with that for a moment. Let the weight of it settle. The universe contains more fire than any human mind can hold. It has produced more energy than all the metaphors of all the languages ever spoken could capture. Stars have been burning for nearly 14 billion years, across 2 trillion galaxies, in numbers that exceed the grains of sand on every beach on every continent on Earth. And still, almost everything is black. Not because the fire failed, not because something went wrong, not because an error was made in the cosmic accounting, because the cosmos is structured in a way that makes darkness inevitable. The distances are too vast, the expansion is too relentless, the geometry is too weighted toward void, the age is too finite, the fuel is running out. Every factor that governs the distribution of light in the universe conspires toward the same outcome. Darkness wins. Darkness has always been winning, and the margin of victory is not narrow. It is so absolute that calling it a victory understates the case. Light never had a chance. Human beings resist this conclusion. We resist it because our entire perceptual apparatus was built to operate in a world where light is abundant and darkness is local. We resist it because our cultural narratives place light on the side of knowledge, warmth, life, and meaning, and darkness on the side of ignorance, cold, death, and absence. We resist it because accepting the depth of cosmic darkness requires accepting something profoundly uncomfortable about our place in the universe. We are not surrounded by light, we are surrounded by void. Our planet orbits a single star in a galaxy that is itself a tiny concentration of matter, suspended in emptiness so vast it might as well be infinite. The warmth we feel, the light we see, the illumination that makes our existence possible, all of it comes from one local source, our sun, and extends no farther than the thin shell of space our solar system occupies. Beyond that shell, in every direction, at every distance, the universe is cold and dark and unlit by anything we can perceive without instruments. We live in a bubble of light no more than a few light hours wide, defined entirely by our proximity to one middleweight star. Step outside that bubble and the darkness closes in immediately, totally, without transition or gradient. There is no gentle fading from lit to unlit. There is our solar system, and then there is the void. This is true for every star system in the universe. Every inhabited planet, if others exist, occupies its own tiny sphere of local illumination surrounded on all sides by darkness that stretches for light years or millions of light years before the next sphere appears. The universe is not a web of light connected by bright filaments. It is a web of darkness punctuated by isolated sparks so far apart that none of them can see or warm any of the others. This is not a failure of the cosmos. This is the cosmos being honest about what it is. Darkness is not the absence of something that should be there. It is the natural, default, structural condition of a universe built from expansion, separation, and finite time. Light is the anomaly. Light is the brief, local, temporary exception to a rule that governs everything else. Stars are not the universe's defining feature. They are its rarest deviation from the norm. For every cubic light year occupied by a star, there are trillions of cubic light years occupied by nothing. For every photon traveling through space, there are volumes of vacuum so enormous that the photon will never illuminate them. The ratio between the lit and the unlit in the cosmos is not close, it is not balanced, it is lopsided beyond any human capacity for comparison. Think of it this way. If the entire future history of the universe were written as a book, with one page for every trillion years, the stelliferous era, the chapter during which stars exist and burn and illuminate the cosmos, would be the first fraction of the first page. Everything after, the cooling, the fading, the evaporation of black holes, the slow drift toward absolute thermal equilibrium, would fill a volume of pages so thick that no library on Earth could hold it. The era of light is not the story of the universe. It is the prologue. A brief, bright, anomalous prologue to an eternity of dark. We happen to live in that prologue. We have mistaken it for the whole book, and the darkness that presses in from every direction, between every star, beyond every galaxy, stretching across the overwhelming majority of cosmic volume and the overwhelming majority of cosmic time, is not the margin, it is the text. And here is the deepest cut. The darkness is not hiding anything. There is no secret brightness waiting beyond the horizon. There is no undiscovered source of illumination that will someday fill the void. There is no future epoch in which the universe reverses course and begins producing enough light to overcome the emptiness. The measurements are in. The observations are complete to within small margins of uncertainty. The cosmic optical background has been measured to extraordinary precision from the outer solar system. The total light arriving from every galaxy across nearly the entire history of the cosmos has been quantified and cross-checked against theoretical predictions of how many galaxies should exist and how much light they should produce. And the answer is, this is it. This is all the light there is. This is all the light there will ever be. The two match. There is no mysterious excess. There is no hidden reservoir. What you see when you look at the night sky, the blazing points of nearby stars surrounded by overwhelming darkness, is not a limited human perspective that better instruments will someday correct. It is an accurate representation of what the universe actually looks like at every scale, from every vantage point, for every observer who has ever existed or will ever exist. The stars are real. The darkness is realer. Every time you step outside on a clear night and look up at the sky, you are receiving a message. The message is not encoded in the starlight, though that carries information too. The message is in the darkness between the stars, in the black gaps that dominate every patch of sky, that stretch between every point of light, that persist no matter how powerful a telescope you use or how long you expose your detector. That darkness is the universe telling you what it is made of. Not fire, not energy, not matter, distance, separation, time, void. The cosmos built itself from emptiness and lit a few small corners of it with nuclear fusion, and those corners are vanishing one by one as the fuel runs out and the expansion carries everything farther apart. The harshest reality of how dark space is does not land when you learn the numbers. It does not land when you understand the physics of redshift, or the inverse square law, or the finite age of the cosmos. It lands when you stand under the stars and realize that the darkness you see is not a gap in the picture. It is the picture. The stars are the interruption. The blackness is the canvas, and the canvas is nearly everything that exists. The universe contains unimaginable amounts of light, and it is still overwhelmingly everywhere, in every direction, at every distance, at every moment in its history, and for all the eons of its future, dark. That is not a flaw in the design. That is the design. Distance is more powerful than brightness. Time is more constraining than energy. Separation is more fundamental than connection. The universe is not a place where light happens to be losing a close race. It is a place where light was never going to win. The fire was always going to be finite, and the void was always going to be vast, and the distances were always going to be too large, and the expansion was always going to drain what light remained. The outcome was determined by the structure of reality itself, written into the geometry of space and the speed of light and the age of the cosmos from the very beginning. No amount of stars would have changed it. No conceivable increase in luminosity would have overcome it. The universe could contain 1,000 times more stars than it does, and the darkness would still dominate, because the volume of space grows faster than any population of light sources can fill it. Darkness is not what the universe is missing. It is what the universe is, and every night sky and every civilization on every world that has ever looked up and seen the black between the stars has been receiving the same quiet, honest, unignorable message. The fire is real, the distance is greater, and the darkness will be here long after every last star has gone out.